All right, so the accompanying data represents the weights of various cars and their gas mileage in the city. The linear correlation coefficient between the weight of the cars and its miles per gallon is this, R, negative 0.97, so 0.972. Okay, the least squares regression line treating weight as explanatory and miles per gallon as response is this. Okay, great. What proportion of the variability in miles per gallon is explained by the relation between weight of the car and the miles per gallon? Okay. You know what I'm going to do? I'm actually going to, just for argument's sake, I'm going to once again pull all of this data into StatCrunch, and I'm going to talk about the statistical output in greater detail and show you how to answer this question from the statistical output. It's actually a pretty easy question to answer from what the information that's given, but I'll get to that after I go through StatCrunch. So, okay, quickly let's do stat. We're going to do not simple linear regression. We've got weight. We're predicting miles per gallon. Let's compute. Okay, some more of the output that we haven't talked about yet. Up here, now you notice that we are given that we're told the sample size and the correlation coefficient, which matches what we were told in the problem. We're told it was 0.972, which is this 0.9719. Then we have this R square, R-SQ, stands for R squared. It is precisely this correlation coefficient squared. If I were to take a calculator and take 0.97190,187 and square it, I'm going to get, oh, it doesn't square the negative. I have to put it in parentheses. But anyway, yeah, it should be positive because it's squared. I forgot that I need to put parentheses around. But yeah, so we'll have 0.944, 5932, etc. That's all R squared is. You take the correlation coefficient, you square it. But R squared has a nice interpretation, which is that's the proportion of the variability of our Y variable, which is explained by the model. In particular, it's explained by weight. So we can just take that R squared, we turned it into a percentage. It's going to be 94.45, rounds up to 94.5. That's what percent of variability of car miles per gallon is explained by weight. Now, let's make a residual plot. What I'm going to do to make a residual plot, go back to Options, Edit. I have some other options down here. I have residuals versus x values as an additional graph that I can create. I'm going to select that and click Compute. It's going to create, if I scroll over to the right, these are the residuals. It's the residual plot. Okay, residual plot for each of the data values. It's going to give you, remember whether that residual is positive or negative. So here's my residual scatter plot, plotting residuals against weight. And you can see this picture matches with choice B. Let's zoom in and just take a closer look. We don't have this dotted line going across at 0, but if you imagine it there, you can see that we have all of these residuals in the exact same place. I'm going to say OK, choose B, and move on with my life. Let's interpret the coefficient of determination. Okay, well, let's see. Let's go back to our data. Once again, the coefficient of determination, that's R squared. That's another word for for R squared. So it's 94.5. 94.5% of the variance in our Y variable, which is gas mileage, is explained by the linear model. So I'm going to look for the choice explained. explained by the linear model. The least squares regression model appears to be what? Appropriate based on residual plot. Why would I choose that? The residual plot looks like just some random cluster of points. That's what you want in a residual plot. If you have a discernible pattern, if you have like a swooping curve, or if it looks like a megaphone or something like that, then that means that something fishy is going on and a linear model isn't appropriate. But if you just have a random scattering of points all around with no real pattern, just looks like a cloud of points, then that means that your residuals, they support the linear model. We'll talk more a little bit about that in later module, but for now you should know if there's no discernible pattern in your residuals, then that means your linear model is probably appropriate. Great.